In this video, we will talk about the Tower of Modulus problem. This video will be in 3 parts. I will pause at each part so that you may pause the video and work on that section. Part 1. Assume an architect has hired you to design a tall tower and wants every 3 floors to alternate color. For instance, floors 0, 1, and 2 are gray, floors 3, 4, and 5 are blue, and floors 6, 7, and 8 are gray, and so on. When you begin this problem, your tower will look like the one on the left. Our goal is to get our tower to look like the one on the right. In other words, as we move up our tower, floors 0, 1, 2 will be gray, floor 3, 4, and 5 will be blue. We can use a modulus to solve this problem. For instance, if we had rem equals floor modulus blank, that blank must make it so we only return the values 0, 1, 2, 3, 4, and 5. And it will repeat like this: 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, and so on, with every floor at 0, 1, and 2 being gray, and every floor at 3, 4, and 5 being blue. Now to do this, we have to use a conditional, and that conditional will be if rem is greater than some number, change the color to blue. At this point, you should pause the video and work through the first part of this problem. We will move on to part 2 in just a moment. Part 2. Our problem here is that the architect thought your design was great, but discovered the tower was too tall for the site they want to build on. Each building must be no taller than 21 floors. You propose making 3 smaller towers, still alternating in colors, even between the buildings. The end result will be similar to a checkerboard. If you completed part 1 correctly, your tower will look like the one on the left. What we need to do now is make our tower look like the one on the right. So to do this, we need to make it so that every 21 floors we move the turtle to a new building. Here I've created a table for you to map out which floors will be in which building. So the first building will be between floors 0 and 20. The second floor tower will be between floors 21 and 41. And the third tower will be between floors 42 and 62. Now we can use a modulus to do this. We're going to add a second modulus to our problem. So we'll have the one for alternating colors, and then we will have a new one for changing buildings. To do this, we need to make rem equal floor modulus and some number. That number must produce the remainder 0 through 20. So that the remainder in each of the buildings will go 0, 1, 2, 3, all the way up to 20. And then it will revert back to 0, go to 20, and then revert back again to go to 20 one last time. Before we move on to part 3, I'm going to pause one last time and allow you an opportunity to complete part 2. Part 3. In this part, the problem is the architects are thrilled with your sketches and want to add even more color to the design. They want you to add a third color to the building's color scheme so that each building has 3 colors using the same every 3 floors pattern. If you did part 2 correctly, your buildings will look like the ones on the left. We now want them to look like the ones on the right. This is a modification of the problem in part 1, so you will not need to modify the code from part 2 to solve it. In part 1, we had 2 colors, where the floors 0, 1, 2 were gray, and the floors 3, 4, 5 were blue. Now we want to change it. So the floors 0, 1 are gray, 2, 3 are blue, and 4, 5 are green. To do this, we will add an additional if statement. Your first if statement will change the color to blue. Your second if statement will change the color to green. To do this, your code, as I stated, will modify part 1. So rather than have the code on the left, you will now use the format